this is where we find out about helper T cell and killer T cell. They grew up together and were both trained the same. And they trained together, and then they're specialized further later. And honestly, helper T cell was pretty cool and killer T cell not too much, but they helped each other. So let's watch this. Completely unaware that there's a completely different intro. What in the world? Listen, it's like rock. My goodness. Is that killer T cell? These are macrophages, obviously. I wonder why they did this for this episode. Like, I do sometimes skip the intro. T cell song is so catchy. Oh, because killer T cells are pretty crazy. They like kill almost everything, so I guess regulatory T cell keeps them in check, like a check and balance kind of thing. Dendrites have a bunch of T cell photos because dendrites also help with T cells. Thymus gland, and that's where T cells mature. Just wanted to look that up. The thymus epithelial cells. It's weird though seeing them outside like this because they're on like the lining of the thymus, so it's kind of weird. The nuance of this show. So I was like, why are dendrites taking pictures and remembering everything? Well, because apparently they have something related to memory. Activity in dendrites is critical in memory formation. Whoa! Dendrites, the tree-like branches of a neuron. That's why the dendrite site is a tree! Wow! Wow! So cute. This is showing his persistence in wanting to be a good... Oh, there I am. Wanting to be a good T-cell commander, or whatever, baby helper T cell comes and sees this and understands. Active element. I found this study, I think, or article from the NIH. There is a real positive selection and negative selection test to find the most lymphocytes. So those, and it's based on their receptors, if they are specific or not. So negative selection is weeding out the ones that are extra reactive or their reactors are extra specific, so they don't want an autoimmune disease or reaction where the immune system starts hurting itself, hurting the body. So that's why it takes out that. And positive selection, which is what we're about to see here, is choosing the ones that are best able to recognize antigens and the receptors are good enough, and those that are not die by neglect, and that's how certain are selected over others. I also wanted to say another thing. So another way that they kind of allude to this receptor things, because receptors are based on the shape, right? Like receptors in your brain will attach to the shape of the thing, and that's how they recognize it. So the way that these cells are recognizing these either good guys or bad guys is they're shown a cardboard thing of it, and it's too smoky to actually see what it is. They have to guess based on the shape of the thing. So that's why it's like a receptor forming to the shape. It has to guess based on the shape of the thing, and receptors are based on shape. I thought that's so cool. And also, I think the negative selection test was in the beginning. That's why that super OP cell turned out to be a helper T cell, because it's was probably going to be too strong to be a killer T cell. It might cause autoimmune disease. That's why it was placed as a helper T cell. They have to find the antigen panels, find the antigens, and search them out. See, it's like a receptor. It's in the dark, so it's not based on sight, it's based on the receptor.